Okay, this is section 3.8, derivatives of inverse functions and inverse trig functions. Okay, so let's pretend I have a function here. Looks like this. Goes through the point a f of a, or we could say ab. Let's call it ab. It has a derivative that looks like this. My function has an inverse. Keep in mind that inverses are reflections over the line y equals x. That looks like this. At the point BA, the derivative, this is f inverse of x. This is f of x. The derivative has a slope. Let's put that in red again. Of m. This has a slope of 1 over m. So inverse functions, if we flip x and y and flip the point, it's important to flip the point, have reciprocal slopes for the tangent lines. Okay, we're going to talk about the derivative of inverse trig functions now. This is the inverse sine, aka the arc sine. I believe that's how I notated it in your formula packet. This derivative is 1 over 1 minus u squared du dx. This is essentially using the chain rule. I should be notating this as arc sine of u, or inverse sine of u. The du dx part is essentially, this is the chain rule built in for you. I believe when I put it in the packet, I have it as just du on top. Same thing. Okay. The arctangent or inverse tangent. And yes, this u thing just is simply allowing us the chain rule. 1 plus u squared du dx. Okay. That is what they are. If you'd like to see them developed, you can look at them in the book. They're doing it with inverses. And there's a triangle that they're showing. Okay. If you want, I can develop them, but I'm not going to for the sake of this video. So, if I am looking at, say, this problem, and I need to find the derivative. So I take this 1 over the square root of 1 minus x squared squared times the derivative of that u, which is 2x. I could simplify that to be 2x over the square root of 1 minus x to the fourth. There's my derivative. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . I can look at it this way. A particle moves at time t equals 0, and this is the next problem, giving me x of t equals inverse tangent of the square root of t. Asked me to find the velocity at t equals 16. First thing I need to do is find phi of t. I'm going to use that inverse tangent formula. Times the derivative of the square root of t is t to the 1/2. So t to the 1/2. Bring the 1/2 in front, subtract 1. There, negative 1/2. Which now I'm going to simplify. 1 over 2 square root of t, 1 plus square root of t squared is just t. So, we should make that a little neater. Now, what it really asked me for was v of 16. One for 2 times the square root of 16 is 4. 1 plus, well, that's not a t squared there. That's not a t squared, that's just a t. One over 8 times 17, which is 136. 1 over 136. Its velocity is very small. If you look in your packet, you'll see the other derivatives of inverse trig functions as well. Um, well, here's the secant. I'm going to have to go find a packet because they don't actually have them all in the book. And these ones are the hard ones to memorize. The inverse tangent is kind of important to just have down because they like to give it as an integral and you have to reverse it. Well, this one's cotangent. And those are your 6 inverse trig functions. One more example. So the secant is 1 over absolute value of 5x to the fourth. I don't really need them because 5x to the fourth is always going to be positive. So because I don't need them, I'm not going to put them. Well, actually, I'll put them in and then we'll simplify this. 5x to the fourth squared minus 1. And then times the derivative of 5x to the fourth is 20x cubed. So I'll simplify that. I'll just move the 20x cubed to the top. 5x to the fourth. When I square the 5x to the fourth, I got 25x to the eighth minus 1. I can simplify some more. That'll cross out 3 of those, leaving me 1 on the bottom. And I get 4 over x times square root of 25 x to the eighth minus 1. And there we have our first trig function, or its derivative.